In this question, what should be the minimum force? This letter P is representing the force. What should be this minimum force so that this small cube, which is in contact with the larger block, may not fall? Okay, so you have to find out the amount of that force, whereas there is certainly a frictional force between the small cube and the larger cube. All right, as well as, and what is the amount of that frictional coefficient? That is 0.71. The masses are given. The larger cube has a smaller cube has a mass 4 kg, the larger cube has a mass 25 kg. And whereas important thing, there's a no friction between the larger cube and the surface. All right, let's find out that quickly. To find this force, first step is to draw free body diagram. Okay, in the free body diagram we will try to find out that which force is preventing the smaller block to fall down. Okay, so let's draw the free body diagram. So we assume that this is a small m, smaller mass, and this is a larger mass. So you know the weight will be downward mg, which is the earth is pulling it down. So which force is countering this force? The other force must be the frictional force that must be in this direction. Okay, so that is a force applied by the larger block on the smaller block. You understand? We will draw these forces in our free body diagram. So that this force is the weight and this is the force applied by the larger block on the upper block. And now remember that what, like at the minimum threshold, this force must be equal to the weight. Otherwise, recommended is that this force must be greater than mg. Okay, okay students, so these two forces must be minimum, these two forces must be equal to each other. And what is a third force? Don't forget, this is a normal force, this is a contact force applied by the larger block on the smaller block, because it is pushing this block in this direction, which is basically, I can say, if I call it normal force, right? So can I say that this is an unbalanced force? So if it is an unbalanced force, then it must be equals to, according to Newton's second law, this must be equal to the ma, the mass time acceleration. Okay students, so if we write our set of equations from this free body diagram, then this frictional force is equals to the weight. All right, and this unbalanced force, normal force, must be equals to ma. Okay, now what is a general formula of the friction force? Everybody knows that this must be mu s, coefficient of static friction, times the times the normal force, right? Fn. Okay, the force that is applied by the larger cube on the smaller cube is equals to mg. Okay, from here, cannot we find out the normal force? Because the normal force will be equals to the mg over mu s. So then it should be, the value of the mass is 4 times 9.8 divided by 0.71. So students, the push of the larger cube on the smaller cube is 55.21 newtons rightward. Okay, and this is causing the acceleration. Okay, yeah, that's equals to ma. Okay students, so what is a free body diagram of a larger cube? Let's find out that the one force that is exerted to the right side on this larger cube is the force which is unknown, right? And what is the other force that is exerted on it? Okay, so in our last part, we have calculated that this is 55.21 newtons rightward. Okay, the same is the force applied by smaller block on the larger block. I'm referring to Newton's third law, that this is a force applied by, they said minimum, what should be the minimum force? So that's why I have to draw the same length of the letter B. So for the smallest magnitude, this is the force applied by Well, this is a normal force applied by the smaller cube on a larger cube, 55.21 Newton. Okay, and what are the other forces? Let's quickly write the weight of this mg, and this is a normal force applied by ground on this. Okay, this normal force, this contact force is different from this contact force. So if you have to accelerate this larger block and this system, then the force, the resultant force, the net force should be P minus 55.21 times ma. All right, and can we find acceleration? Yes, it was 55.21 times 4 kilograms and a, and you can find a value. So acceleration of the system is 13.80 meter per second square. Okay, so now we will plug the value here. 55.21 is equals to, what is a mass? That is 25 kilograms times 13.80, and then you can take this on the other side of the equation. Okay students, so finally we got an answer that is 400.21 Newton is the smallest force which is required in order to keep this smaller cube stick with a larger cube. All right, so it means that this force is much bigger than 5.21. So I'm retrying this vector again, and now this time I will draw the smaller arrow. Okay, because this force is small. All right, so I hope you understand this question.